Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving deep into the surprisingly complex world of null pointers, specifically the common misconceptions surrounding them. It's way more nuanced than you might think.
Yeah, I've always assumed dereferencing a null pointer just instantly crashes everything. But this article suggests it's not that simple, right?
Exactly. The first big misconception is that it always crashes. While a segmentation fault is common, especially in C or C++, higher-level languages and clever exception handling can actually catch and recover from a null pointer dereference. Think Go's panic and recover, or Java's null pointer exception.
Wow, so it's not an automatic death sentence for the program? That's unexpected. So what about the hardware level? Does it always throw a signal or exception?
Not at all. Before virtual memory, accessing address 0 was just accessing address 0. Many embedded systems still work this way. Even on modern systems, things like WebAssembly and, believe it or not, Linux with specific flags can map memory at address 0. It's all about how the operating system and hardware are configured.
Hold on a second. Linux mapping memory at address 0? That sounds like a huge security risk.
It absolutely was a security risk, which is why it's disabled by default now. But the point is, the behavior isn't universally consistent. The article even mentions that on some GPU architectures, the null pointer isn't even represented as 0.
So the whole null pointer is always address 0 thing is a myth? The C standard doesn't even mandate it, right?
Precisely. The standard only requires that void 0 is a null pointer. The actual address can vary depending on the architecture or even the C interpreter. Some architectures use non-zero null pointers. It's crazy.
This is blowing my mind. So, if the address isn't always 0, does that mean int x equals 0? Void x is always a null pointer?
Nope. That's another misconception. Because x isn't a compile time constant, the conversion is implementation defined. It could be a null pointer, but it doesn't have to be. It could even point to a valid memory location at address 0, depending on the compiler and platform.
Okay, I'm starting to see a pattern here. It's all about the nuances of implementation and how different systems handle things. What about comparing pointers? If two pointers have the same address, are they equal?
Not necessarily. The article highlights the importance of pointer provenance. Two pointers might have the same address, but if they originate from different places, like one from a constant 0 and the other from an object at address 0, they might behave differently. Dereferencing one might be UTMB, while the other might be perfectly fine.
That's mind-bending. So what's the takeaway here? Should we just avoid null pointers altogether?
Well, that's not practical. But the key is to understand the complexities. Don't make assumptions. Check the standard, check your compiler's documentation, and most importantly, document your assumptions. Treat C as a higher-level language, not just portable assembler. Use safer practices, let the compiler optimize where possible, and avoid unnecessary pointer manipulation. And always document your assumptions.
Excellent advice. This has been a really insightful discussion. Thanks for clearing up these misconceptions.
You're welcome. And that's all the time we have for today's Tech Bytes and News. Join us tomorrow for more deep dives into the fascinating world of programming. Goodbye.
Bye-bye.